Today's lesson, section 11.4c, talking about shifted conics. And so now, another possibility for conics is that you could have conics that are rotated. Okay. Now we're not going to graph any rotated conics, so don't worry. But we want to be able to identify conics, especially when their general form is not easily changed into standard form. So here's their general form for an equation for a conic. So you have an ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now the part of your conic from the general form that makes it rotated is this bxy term. So this causes the rotation about the center or vertex, whichever one you're talking about. Okay, so that gives you pictures that look like maybe an ellipse that's elongated that way, or hyperbolas that kind of rotate in this direction. Okay, or you have parabolas that have a vertex out here, and then so they open like to the northwest almost, if you're thinking about that way. Okay, so now for those ones it's hard to put them into standard form, and there is a way to be able to do it. It's not like it's impossible, but we're not going to spend our time on that. We do want to be able to identify what those shape or those conics are, so we use something called discriminant. You remember that from the quadratic formula. This was the review assignment at the beginning, and so we kind of talked about it briefly, how to use that. And so for the graph of the equation in general form for a conic is either a conic or a degenerate conic. In the non-degenerate cases, the graph is going to be the following. So if it's a parabola, that means your discriminant, so b squared minus 4ac, is going to be equal to 0. So it's kind of like if there was one real solution, if we were looking at a quadratic formula. Okay. In an ellipse, b squared minus 4ac is going to be less than 0, so that would be like if there was no real solutions. And then hyperbola is when b squared minus 4ac is greater than 0, so like if there were two real solutions. So all the same concepts, except applying them to something a little bit different. So example 3 says we want to use the discriminant to determine whether the graph of the equation is a parabola, ellipse, or hyperbola. So letter A, now just because you're going to be given a D, an E, an F, or maybe one of them, or all of them, or none of them, okay? So we don't care about that. So like 49, I don't care about number 49, okay? I'm only concerned with my A, my B, and my C. So I plug those in. So negative 48 squared minus 4 times 17 times 31. Now the only difference here for your discriminants, the numbers are going to be a lot bigger, okay? So be ready for that. So negative 48 squared is going to be 2,304. And then negative 4 times 17 times 31 is 2,108. So that means our discriminant is 196. That is greater than 0, so that means this is a hyperbola. Okay? Letter B, same thing. I don't care about the negative 2x or the AY or negative 50, so I'll plug in my B, which is 11 squared minus 4 times 10 times 9. That gives me 121 minus 360, and that equals negative 239, which is less than 0, so that means this is an ellipse. So You already know how to use the discriminant. We're just kind of applying it to a different thing here, okay? So, have fun.